All right, everybody, welcome. This is DevOps at Scale, achieving a zero downtime migration for 80 million daily requests. For those I haven't met yet, my name is Kyle Hoehns. I have been professionally tackling software problems since around 2011. So I'm getting up there in age finally. Source Allies, I've been working here since 2021, so almost 4 years here in June. And I'm also one of the organizers of the Central Iowa Java Users Group. So if you're interested in another user group that you can kind of go to here in Central Iowa, please check us out. We're usually every Thursday, third Thursday of the month. We just wrapped up, I know we have lightning talks coming up here pretty soon, so hopefully we can see some of you guys there. All right, so let's set the stage. This is all going to be a presentation that is about something that actually happened. This was a project that Source Allies was brought into to help a partner out of a tricky situation. So throughout this presentation, you will see real AWS architecture diagrams. You will see real problems, and you'll see how we solved them. However, I'm going to leave out some of the nitty-gritty details to protect, the partner's IP and kind of their identity and that kind of stuff. So with that being said, let's roll ourselves back. This was probably a year and a half ago, and it's a Monday morning. So it's a Monday morning. You're loving that you have to go to work, right? Everybody loves it. We're all slamming our alarm like Bill Murray here in Groundhog's Day. Nobody wants to get up. Nobody wants to go to work. But you get a fresh cup of coffee. Things are feeling good. You're relaxed. You're ready to go. You're excited for work. But you come and you log in, or either you go downstairs to your basement, to your office, or you drive into work. And the second you get there, it kind of looks like this, right? Everything's on fire. And it's a problem. What a great way to start Monday, right? Your on-call is getting flooded with alarms and alerts. Emails are going crazy. People are calling in. And the API you own is performing like a snail. And that was the situation we found ourselves in. Our team owned several high-traffic APIs. And so these APIs, I like to think of them as, when you think of the APIs in an enterprise, you can kind of think of them as a hub wheel pattern, or a wheel pattern, right? Some are more core than others. And ours was kind of at the middle of the enterprise. So a bunch of people called us, very high traffic. Like it was in the title, it was 80 million requests a day, I think was the peak we had at the time. And so we couldn't go down, super high traffic. We also owned a document-based data store with nearly 1 billion documents inside of it, all serving and getting served out of those APIs. And we also owned the ingestion pipeline to populate that data store. So when our alarms are going off and everything's on fire, for better or worse, we own that entire stack. We own the API, we own where it rests, and we own how it gets in there. So when things are going wrong, it's on us. All right, so let's talk a little bit about the architecture. This was a partner that was in AWS, so all of this is going to be an AWS architecture. However, I'm hopeful that these concepts could change regardless of what cloud provider you're on. We'll start with the ingestion side. So over here on the left, we have AWS Kinesis. For those that haven't used Kinesis before, it's basically a message queue. So some message gets put somewhere, and you have an application or something that's listening to it, and you want to act on it. That's what we used Kinesis for. If you've heard of like Apache Kafka or RabbitMQ or Amazon's SQS, it's all the same thing. It's just a great way to buffer yourself from other systems, right? Our application was buffered from people sending messages to us, and then we would act on them. What we had after Kinesis was an Elastic ECS cluster, ECS cluster. That ECS cluster, for those that haven't been in there before, is Elastic Container Services. Basically, this is a great way for you to say, hey, AWS, I have this Docker image, and I want to deploy it 10 times with these parameters. Maybe I need this much CPU, this much RAM, et cetera, and it just runs it. You don't have to care about it. It's been great. All my experience with this has been really, really nice. But what we had is we had that ECS service listening to Kinesis. So a message would come in, and our tasks in that ECS cluster would process the data. And we would process that data into OpenSearch. And so for those that haven't worked with Elasticsearch or OpenSearch before, a lot of times I feel like people have seen Elastic with logs. So most of the time, it's a great way. If you haven't heard of the ELK stack before, that's Elastic, Logstash, and Kibana. So Elastic is the E in ELK stack. It's a great way for you to send data somewhere like logs and say, hey, give me all the error messages that happen between time A and time B. Works really slick, really fast for that. Another thing that people use Elasticsearch for a lot is full text search. So for example, if we had a store application and inside that store, maybe we have office products like we've got in the room here today and we have chairs. So I can search for chair and it'll find me all the chair documents really quick. I can find all those products. It's great at that. And the other thing that it's really good at and what our use case was for was aggregating data. So if, for example, we had our products store and each product in that document-based data store had a price on it, Elasticsearch can really quickly aggregate and figure out what's the average price of every chair sold between days A and B, stuff like that. It's super snappy at that. And that's what our use case was for. So we had ingested a bunch of data. We had 1 billion documents in here, and we did crazy aggregations with Elasticsearch. So that's our ingest side. On the other side, we have our API stack. The API stack has a whole bunch of consumers over here you'll see. So we had things like other internal applications. We had mobile apps. There were web apps. There were auditing tools, reporting tools. About anything you could think of in an enterprise is hitting our APIs. We also had third-party external clients. So it wasn't just within the enterprise, it was also external as well. All of those clients roughly would hit API Gateway. An API Gateway, if you haven't used it before, is done for authorization and authentication. And API Gateway would forward requests off to AWS Lambda. So for those that haven't seen Lambda before, it's a great way for you to write a small function, and it scales incredibly, incredibly fast. So like I was saying earlier, we have so many consumers and so many different consumers that our call patterns were all over the board. You never know what third party is going to start calling our APIs, and Lambda let us scale incredibly high and adjust to demands. And so that was our stage. The morning that everything was on fire, the root of the issue was our OpenSearch cluster. And so our OpenSearch cluster was not behaving up to the performance expectations that our clients were. So we were starting to break SLAs, and people were getting angry. This wasn't that the whole thing was down and broken and you know, true fire, but things were slow enough that our team needed to react because we were such a core API. In order to understand kind of more about how our cluster got to the state it's in, I want to do a little bit of a deep dive on Elasticsearch 101. So like I said before, Elasticsearch is a distributed search and analytics engine. Data inside of Elasticsearch is stored in something called an index or an indices if you have multiple. You can think of that as something similar to a table in a relational database. Inside of each index is a shard or a group of shards, and those shards are small little segments that are used to store data. Those data segments, those shards, are used to help Elasticsearch scale. So you can have primary replicas where data gets written to, and then read replicas where data is copied to. So for example, here is an Elasticsearch cluster. If you wanted to envision 3 different nodes in a cluster, this green box here is our index, and inside of each index, you have a concept of primary shards and replica shards. In this example, we have 2 primary shards to indicate the 2 different colors, and then the read replicas. If you want to scale, like Elasticsearch says, you just add more nodes, and your new nodes get read replicas. Works pretty slick, right? And it's very high fault tolerant, right? If one of my nodes goes down, I already have all the data somewhere else. I just need to decide a new primary, and Elasticsearch handles that for you. Works really slick. Once you get to that point, there's a idea or an indexing strategy that you need to come up with pretty quickly once you create your Elasticsearch index. And your goal is to make them a manageable size. Remember, I talked about the ability to scale based on the size of these shards. For example, if I have a brand new application, like we were looking at earlier, maybe all the shards are 10 to 11 gigs. They're tiny, they're manageable, they're easy to move around, it's easy to scale. And what happens is when you get big enough, you want to set a upper limit or a bound on how big a shard should get. And the usual recommendation is 25 to 50 gigs about. Once you get into that range and you get bigger than that, things start to cause problems. And so what you end up doing is you'll end up kind of locking down an index and spinning up a brand new index, where new writes will go to index 2, Old writes or old reads can still happen on index 001, and you still get all your data. Once you start getting a bunch of indices, it would be hard without this concept of an alias to figure out where your data is at in an Elasticsearch cluster. So Elastic has a concept called an alias, and inside that alias, you can reference a whole suite of indexes. So if I, as an application developer, just say, hey, alias, go find me some data, and Elastic is smart enough to just search through all your indices and find your data. And this grows really well. You can add tons and tons and tons of these indices behind a single alias and handle everything perfectly. Why does any of this matter? Mostly performance, like we talked about earlier. If Elastic likes to run in a concept where I think it tries to have as much data as it can in memory at one time. So you usually have big Elasticsearch boxes. The bigger your shards are, the worse your performance can be, because you got to try to load it all into a huge box. Also manageability, like I talked about earlier. If you want to scale, if we're on three nodes in a cluster and we want to scale to 4 or 5, if you have huge shards, moving that data across can be a nightmare. And also for stability, right? If, like we were talking about earlier, if one of your nodes in your cluster goes down, the time it takes to spin up another node with the exact same huge shards in it takes a long time to copy all that data across. And so all that combined kind of leads to what our actual cluster looked like. So this was our cluster architecture at the time that we kind of had the problem. We had one index. We had no aliases. We had a bunch of shards, and it worked great for a while. Our application worked great. Performance was awesome. We were handling so many requests. But then things got bad. We started getting these shards that were 90, 80, 100 plus gigabytes, and things were starting to slow down. That was our fire. So something we needed to change. We tried a few things. We tried to scale up. We tried to scale out. Every time we did it, we ended up getting better performance at the end, but because our cluster was so poorly set up, the act of actually scaling brought performance down for everybody. So we knew that, like, yeah, we knew we needed to scale. So it's like, all right, we got to do it. And then we did it. And for like 3 or 4 hours after we tried to scale, things were terrible until it kind of resettled itself and got going. So any scaling scared the team. We also talked to AWS support, right? We were hosted on AWS. Hey, you guys own OpenSearch. What's a thing we should do here? What should we do? And everybody we talked to online basically told us that your foundation is busted. So when your foundation's broken, you don't just keep decorating the house. You're forced to rebuild. And so that's the kind of tough pill to swallow that our team ran into. And that's what this talks about. So our plan of attack, we needed to move from OpenSearch to Elasticsearch. Now, this is a fun open source problem for everybody. Elasticsearch used to be open source software. It actually is again now. So this is a weird, it's been weird. So Elasticsearch back in January of 2021 changed their licensing. So people like AWS can't just host Elasticsearch for free and make money off people like us. So what ended up happening is in January of 2021, when the license for Elasticsearch was changed, the community went back to the commit prior to the license and forked it into OpenSearch. And so that's what OpenSearch came from. The enterprise we were working with had decided that they didn't want to mess with that. And so we just went to the Elasticsearch SaaS offering. So that was kind of a card that was dealt to the team. We had to handle that. We couldn't just stay within AWS for this project. So we knew we needed to get the data across, but we had some challenges. We had a lot of data. Like I said earlier, it was 1 billion documents and about 18 terabytes of data like when you're talking about replicas and stuff like that. So just raw size of the original data. We also had data integrity, right? We had all those requests coming in. How in the world do you copy all the data from one cluster to another cluster and hope that everything just magically shows up in the other place? Those were big challenges for us on data. And luckily, we kind of stumbled upon Logstash. So like I was talking about the Elk stack earlier, the L in Elk stack is Logstash. Logstash is open source. It is a data processing pipeline that takes data from sources and stashes it somewhere else. Logstash. So I like to think of it as a picture kind of like this, where you have some sort of input from somewhere, you have some amount of filters if you want them, and then it outputs somewhere. It's just a pipe. So for example, maybe I have log files in CloudWatch. I've got log files. I want to filter it to just log files that have errors, and then I want to write them to an S3 bucket. Logstash can do that. Maybe I have data like pictures in an S3 bucket, and I want to filter them out and write it to a different S3 bucket. Logstash can handle that. And luckily for us, there was an input plugin for OpenSearch, and there was an output plugin for Elasticsearch. So that's exactly what we wanted, and that's kind of the route we went. So our plan of attack was we were already comfortable with ECS at this point. We were going to just take Logstash and stick it on ECS and copy that data from OpenSearch into Elasticsearch. We already knew it could scale well. We already knew how to work with it. We already knew everything about ECS, so that seemed like a no-brainer for us, and it worked really well because it could scale so wide and because we could handle the traffic. So what we ended up doing is on OpenSearch, all the documents we had here had a timestamp on them, basically, a version timestamp of, hey, this is when I got inserted into the document-based data store. I came in January, I came in July, et cetera, et cetera. We had timestamps on all these documents. What we ended up doing was in ECS, kind of fanning out our Logstash and saying, hey, start copying all the data between this date and this date up to Elasticsearch. And then you could spin as wide as we could and copy all the data across. That worked really well for us. The thing we had to watch out for is we didn't scale too wide. Remember, this OpenSearch cluster is on its last legs. So if we scale this too wide and try to go too fast, we would negatively impact OpenSearch down below. One of the great things we did while we did this migration is the filters in the middle of Logstash have a concept of a mutation filter. And so we could take a document, and when we moved it across, we kind of rubber stamped it or tagged it with what the migration ID and the timestamp were. And what that let us do is if things failed, for example, I'm doing migration 1 and I'm between January and March. Maybe I get to the February documents and this migration fails. You know, OpenSearch goes down or I get throttled somewhere. If something happens, we can really easily go up to Elasticsearch and say, hey, what was the timestamp on migration 1 that you have the most recent copy of? And we'll just restart from there instead of having to redo the entire migration. We knew exactly our processing. So that'd be something if you guys are doing migration, maybe think about adding some timestamps or some metadata onto your stuff as you're moving them across. So at this point, we knew how to copy data from OpenSearch to Elasticsearch. The question at this point becomes, how do I read data from both and how do I write data from both? And we kind of thought about it for a little while, and it didn't take the team more than 5 or 10 minutes to kind of poke holes in this approach, mostly because we were very low risk tolerance. Like I said earlier, if we go down, everybody in the enterprise is angry. It was a no go down, we cannot go down situation. We also had a challenge of maintaining a record of what happened during the transition. So the problem we had is we thought that copying all this data from OpenSearch to Elasticsearch was going to take us about 5 business days. That copy time, if for some reason on a Monday we copy the data across from Open to Elastic, on Tuesday if a document update comes in that deletes that document, we've kind of lost it up here. Or maybe the delete comes through here, but we hadn't copied the data across yet. There's like all this out of sync stuff we get into. And so those two things combined made us go to dual ingestion stacks. Why? We need to keep live traffic moving, right? So we just decided we're going to take our existing ECS application and we're just going to fork it. We were using infrastructure as code, and since we're using infrastructure as code, all we had to do is go change a couple of environment variables or variable names in our application code, and we spun up a whole new task. Super easy. If you guys aren't using infrastructure as code at your partners, highly, highly recommend. This would not have been possible if we were not able to easily just say, hey, take your 20 prod servers and just put them over here with a slightly different name. I've worked at places in the past where you have to call up the WebSphere admins, or you got to call somebody and be like, hey, what are the odds you can just copy all this data and put it over here? It's like 0% chance it would work. Infrastructure as code made this incredibly, incredibly easy for us. What else we got? When we made that change, we had to make changes to Kinesis. So Kinesis, I was talking about earlier, is like a message queue. It's really kind of like a time series database is another way to think about it. It gets messages from the consumer, and instead of, I don't know, like if you guys are familiar with an SQS or an SNS, those message queues, once you read a message, you acknowledge it, and it kind of disappears off the queue. It's gone. It's not there. Kinesis is different. Kinesis, the messages are there until there's a retention period where it's kind of deleted, where I have my existing application. Once it reads a message, it's good to go. But we can have multiple consumers of those same messages with Kinesis. And so what we ended up doing was changing the retention period. While we were going to copy all this data from OpenSearch to Elasticsearch, we turned off this consumer, and these messages could just start backing up. So we changed the retention period. I think the default in AWS is about a day. We might have changed that back to like a week or 2 weeks or whatever we felt we needed to kind of get that data copied across. And while all that data was copied across, we were effectively building this giant traffic jam, but like a happy traffic jam, not like a people are angry traffic jam. So we turned it off maybe on Monday and had live traffic flowing through, and this traffic jam just started building up. And then maybe on Friday or whenever we got through, we finally turned the application back on, and we start processing the messages in the same order they were processed, only like 5 days late. And so that's what we ended up doing with Kinesis. We also had to make application changes. Because we were doing the alias instead of an index, we had to make some kind of core CRUD operation changes to our application stack, and also needed different authentication. We weren't doing AWS environment anymore, so I didn't need an AWS account and all that good stuff in order to do authentication. I now needed tokens and all that. All of those things combined, all of those things combined made it so it was much easier for us to get things accomplished, right? If we were worried about core authentication changes without having forked the repo and spun up a whole new stack, I don't know about you guys, but if you ever do authentication, like the first try in code, it doesn't work. It probably doesn't work till the fifth or sixth try, right? And we couldn't impact prod, right? We couldn't impact the production traffic. So it was easy for us to fork it, play around up here, make all the changes, make all the mistakes that you're used to making in an agile environment, all by yourself without impacting production. All right, so what about the API? We still had all these consumers. All the consumers are still hitting it, but they're still just going down here to OpenSearch. We did some Canary deployments. For those that have not heard of Canary deployments before, this is a way for you to send or route some of your partner or some of your API traffic or whatever traffic you have, kind of one route versus another. So we were going to slowly add our search traffic to Elasticsearch with the goal of no big bang. We were not going to just flip the switch and 100% of traffic was going to be flipped over. We knew that was risky, and we were risk averse. So we were going to just slowly start flooding our traffic in. And we came across this concept called a weighted lambda alias. So within AWS, they have this awesome concept that we kind of stumbled upon where you can do this canary routing. Basically, every time that you upload a version of your code to AWS, that lambda gets a new version. So the first time you put it out there, you're version 2, and then you make some changes and push your code, and it's version 2. Within AWS, you can configure an alias, and that alias has a couple of routing parameters on it that let you do percentage-based routing. And so that's what we ended up deciding to go with. And what that allowed us to do is we didn't have to care about it. AWS handled it. You just say, hey, send 99% of my traffic to this Lambda and send 1% of my traffic to the other Lambda. And it just worked. Super easy. Would highly recommend if you guys have something where you're trying to spin 2 different versions up. What we ended up doing was having this second version that talked to Elasticsearch. Again, because we didn't want to touch this guy if we couldn't. This was the same code base, but we had this Lambda had some like different environment variables or feature flags enabled that said, hey, your version should be talking to Elasticsearch. So the app could write to both at the same time, but we kind of split it and kept it isolated. So we effectively got ourselves into dual stacks. We're ready to go, right? Not quite, because you can't manage what you can't observe. We were getting ready to do this entire thing in prod. Huge impacts if we mess up. You need to make sure you can observe it. So this slide is titled Observability Requirements. Notice I did not title it Observability Nice to Haves or Suggestions. You as an app developer should be asking for these things at your partner, or your business, or whoever you're working with. Please, 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 you need to be able to see how your application is doing in production. I'm a big advocate for your application is deployed somewhere, you should know how it's performing before everybody else tells you how it's performing. So we built dashboards of things like error rates, latencies, and total traffic. We had dashboards set up with your side-by-side error rates. We could see the error rates of OpenSearch and the error rates of Elasticsearch going right side by side. Same with latency and total traffic. I remember we had a pie chart set up, and you could see a 1% sliver of data going one way or the other. This allows us, and you'll see later in the talk, this allowed us a lot of confidence, and we would know if things needed to change while we were doing a rollout. So our rollout strategy, where we landed once we got everything comfy, is we wanted to fully migrate our lower environments. You guys have test environments, right? Because you test in test environments. All right. If you don't have test environments, advocate for test environments. You should not be doing this stuff in production. So we're going to fully migrate our lower environments. And we did that multiple times. We have a test environment. We're going to try to migrate the data from OpenSearch to Elasticsearch. Inevitably, it doesn't work the first time. You iterate, you change, you make a change, you make whatever changes you need to make to get that out there. We did that several times. I bet by the time we were fully done, our test environments we did 10 times, fully migrated. And what we did each time we were running into problems was create playbooks. So for those that haven't seen playbooks previously, this is like you going out to Confluence or GitHub or wherever you like to store your documentation for your team and just being like incredibly detailed. We did a lot of screenshots. We did like screen recording, that kind of stuff of saying, hey, what if I need to change the weighted routing for the Lambda alias? What do I do? Or, hey, if the data migration fails, like we talked about earlier, how do I find the right timestamp? What do I need to do to kick this off? Who knows how to do this? All of this was really meticulously documented for us, just in case somebody wins the lottery and all of a sudden they don't come in. You know, you don't want to be the one person that knows how to do this whole migration. Everybody on the team knew how to do it because we did it so many times in our test environments and we documented it. We felt really comfy. We got to production and it was like, we've done this so many times, we were just sick of it. We didn't want to, it was like, it wasn't exciting, right? Once we made all those migrations, we also let them bake. So our test environments, we made the migration, fully cut them over, and just let them sit for like a week or two. And so I don't know about you guys, but in our test environments, in this environment, it might be like you make a change on Monday and then Thursday rolls around and somebody's like, hey, you gonna go make it, you guys ever gonna fix that thing you broke in the test? Like, you know, in prod, the problems prop up a lot quicker. In test, just let things bake, see what happens. And your ultimate goal here is to make production boring. Like I said earlier, we did this in test environments so many times that we got to prod, it was a non-event. The team was like, oh, we really have to do that? I thought we were done with the project, but we weren't. All right, with all of that in place, we were ready to start doing a cutover. So in this diagram, we've got green arrows and red arrows, and I apologize to anybody that's colorblind, but we'll call that out. All right, so in this example, everything green is live production traffic. Red is things that are turned off, nothing's happening. So at this point, everything, 100% of traffic is going down here to OpenSearch, and while the traffic's going, we are migrating data. While the migration's happening, our ECS, our new ECS tasks are shut off, and this Kinesis message queue is backing up. This is exactly what we wanted. All right, let's see. We flipped off after the data copied. I think it took us about 5 days to copy all the data. Once all the data copied across, we turn back on ECS, and Kinesis starts catching back up and writing it into our Elasticsearch cluster in prod. At this point, once all the data had been copied over, we had things like querying document counts, and we had certain entities we wanted to query between both clusters, ran all those, made sure document counts were within the bounds we wanted, made sure that all the queries showed the data we wanted to see. And we felt comfy. We thought all the data's there. It's been running. It's been writing. Let's flip the switch, right? Let's see what happens. And we flipped 1% on. So we made it to prod. All the data was here. And 1% of customers, whether they knew it or not, were going to Elastic instead of OpenSearch. Their data is in 2 spots. It's just kind of up to a dice roll on where they get it from. This was an exciting day for the team. I know that, like, I don't know. For all that work, we made this change, and 1% doesn't seem like a lot, but when we're handling 80 million requests a day, that's 800,000 calls going to Elasticsearch. And we were a little nervous, we were excited, we were having a good time. Great day for the team. What we ended up doing is kind of part of our agile processes is during things like stand-up or during kind of our daily get-togethers, we would bring up our dashboard that we talked about earlier. So we were talking about, hey, here's the latency of what's going to Elasticsearch. Here's the latency of what's going to OpenSearch in production. Does it look good for the last 24 hours? If it does, we might say, all right, thumbs up, everybody's in agreement. We're going to bump it up to the next level. one of the things I want to call out here before we do that is we looked at that at stand up each day before we made the call. I don't know about your guys' call patterns, but our call patterns, especially because we had like reporting tools and audit tools, between like 1 a.m. and 3 a.m., we get crushed. Everybody wants to hit. So don't get excited. Don't flip to 1% of your traffic at 8 a.m. and then flip to 10% before you go home for the day. Like, hey, we handled it today. No, you didn't handle it today. You handled it for a portion of today, right? So the last thing you want is somebody to get an angry wake-up call because you don't know what your traffic patterns look like. So we let things bake for a day before we made another move. So we might have set at 1% for a day or two, probably because we were nervous, and then bumped it to 5%. Again, let it bake for a day, review it, go slow. Maybe we'd get to 10%, et cetera, et cetera. And we kept moving. Eventually, we got up to about 40% of traffic. And we kept doing the same process. And when we got to 40%, we could see a visible difference in our latencies, right? So our latencies for going to Elasticsearch were a little bit higher than OpenSearch. Previously, it was the other way around, right? We re-architected Elasticsearch. This was a lot faster. All of a sudden, we get a lot of traffic in there, and it starts slowing down. Not slowing down to a point where customers notice. It might be 100 milliseconds or 50 milliseconds, but what used to be under is now over, and it's like, whoa, pump the brakes. Something's going on. And so it was easy for us. We had the documentation. We knew how to flip this, and we flipped her back to 20%. Everything goes back to green. Life's good. But we realized that we needed to scale out our Elasticsearch cluster. Now, if you rewind earlier in the talk, we talked about how when we used to scale OpenSearch, this was like a scary thing. We had to let everybody know, right? When this thing scaled, it ruined the day for everybody. But what happened here is because we changed our foundation, we re-architected it correctly. When we had to scale out this Elasticsearch cluster, it just worked. And it was a non-event. Again, this is probably like day number 2 exciting thing for the team. We were having some traffic. We scaled. Nobody noticed. It was great. After that, we flipped it back. After the scaling was done, we flipped it back to 40%. Everything's green. We're back to normal. And eventually, we made it all the way to 100%. It was a slow roll, but we got there. Day probably number 3 of excitement for the team as we finally got everybody off. It was exciting, but it was almost like a letdown, right? Because nobody knew we did this. Aside from the internal people, it wasn't like a customer project where it's like, oh, yes, this new feature's out in prod. This is the best. It's just like, hey, I'm still getting my data. This is great, right? But for the team, this is a big deal. We made it happen. So today, here's our layout. Because I said we were using infrastructure as code, we let this stuff stay around for a while, especially our data backups, just in case something got screwy. Maybe let that around for a month or 2. After that, tear it all down, and this is where we're at. It was great, right? We effectively replaced the engine of our airplane mid-flight. Previously, this said OpenSearch. Now it says Elasticsearch. In theory, that's all we really did, but it was hard to get there. So in summary, if you're going to take some things away, zero downtime is achievable. Prior to this project, I was like, I don't know if we can really do it with zero downtime. It is achievable. However, I'll put a caveat on, like, it depends on your use case, right? If your application that you guys are working on is only a business-facing application and it's only used between 8 and 6, if you go down for 3 hours some Tuesday night or on a weekend, that's probably okay, right? For us, downtime was not an option, but it is achievable. It was kind of fun. Infrastructure as code was essential. For me, if we could not have easily spun up our dual ingestion stacks or our dual API side stuff, we would have tried to use the existing infrastructure and the existing app, and we would have tried to make authentication changes, and it would not have worked. We would have impacted performance. We would have impacted the customers somehow. Also, observability is non-negotiable. When we were migrating, we're flipping, and we're watching the charts, if we didn't have those dashboards in place when we finally got to 40% and we started feeling comfy, we would have kept going and everything would have crashed. Have to be able to observe that stuff. Iterate, practice, and prepare as well. You have test environments for a reason. Please use them. And your main goal there is to make production an incredibly boring place. And that's it. If you guys want to connect, I'm on LinkedIn. I know you guys all want to connect with me there. But open to questions. Any Anything? Oh my gosh, hands up everywhere. All right, let's go, Matt. Sorry, I'm gonna bring the mic. Maybe I'll bring the mic if I can figure out how to get it off my. Or just give him a. Yeah, there you go.
So in your lower environments, when you were doing the migration, were you doing the migration under load? Like, were you simulating production load in those environments while the migration was happening?
Good question. No, basically, unfortunately, we did run some load testing tools. Like our team's been really going around on K6 a lot lately. Just really easy way to do load testing. But no, unfortunately, at this scale, unless somebody has the info that they could provide me on like how in the world you at this scale replicate that scale in a test, it's a pain. It's so hard. There have been things where we've tried to not necessarily scale wise, but like recreate requests. For example, there was a time where we were thinking about, maybe I'm going to scrape like 0.1% of all the requests and like copy their response objects here, like copy the responses and then also run them against this new stack and try to like make sure they're the same all the time or something like that. But no, we didn't run it. I would love the answer to that. It would be expensive to like spin up the entire production infrastructure again and then like route. Ideally, that's what it is. But I think from a cost standpoint, it's a nightmare. Any other questions? All right, Sean, I'm coming.
I'm curious if for your buffer everything and Kinesis strategy, if you did any math or thought about what happens if the migration takes so long that we can never get caught back up.
Yeah. That's a good question. So what happens if we can never, ever get caught back up again? Luckily, if the Kinesis stream drops, luckily for us, the consumer above us has the ability to replay data. So worst case, we say, hey, team above us, you go replay data for the last month. I'm sorry. And then what would happen then is both of our stacks would have ingested, basically replay the data. So it would have been okay. It would have been a pain, but we would have made it work. Any other questions? Anybody online? Is the chat clean? I don't know. Okay. Sweet. All right. That'll be it.